the civil engineering project manager for Vigor Shipyards. I work here in Seattle. I occasionally do projects for our facility at Swan Island in Portland. My two primary consultants on this project have been Floyd Snyder and KPFF. I'm going to give you a little background on Harbor Island and Vigor and our regulatory environment. And then I'm going to step into two projects that I'm presenting on today. Harbor Island, all of Harbor Island is a Superfund site. It was declared a Superfund site back in the 1980s. The way Superfund works is EPA isn't necessarily concerned with who caused environmental damage. What they care about is who has the ability to perform and pay for the cleanup. When Vigor purchased Todd Shipyards in 2011, we acquired all the responsibility for the cleanup. And part of our settlement for the environmental damages from the Superfund site is where all these projects began. Our facility is a 27-acre campus. We're on Harbor Island, right at the mouth of the Duwamish River and Elliott Bay. We have 3 floating dry docks, 4 piers, 12 cranes, and we primarily do ship repair, vessel maintenance, and work on ferries, barges, and military vessels. Before the 1900s, this is what Elliott Bay looked like here on the left. This would have been a large tidal area in the south end of Elliott Bay. The nice meandering channel of the Duwamish River. They began industrializing this area in the early 20th century. Large sections of Seattle is infill, Harbor Island's all fill. Here you have Terminal 30, Terminal 15 here on the east side of, or 18 on the east side of Harbor Island, and Terminal 5 over here in West Seattle. And then the Duwamish River was channelized and dredged deeper and armored as part of this process. And basically that destroyed all of this intertidal mudflat and the river delta. Harbor Island itself was constructed in 1909. The main portion of it, it's 420 acres. Literally billions of cubic yards of material was brought in from regrading projects around Seattle. And it was the largest artificial island until 1938. Shipyard activities began on Harbor Island in 1918. So this picture on the left, the shipyard's about 10 years old. This building here, most of it still exists today. It's right here on the north end of this white roofed production building here. Most of what you can see here is what we refer to as the Southwest Yard. Over on this side of the facilities are stormwater tanks. And so you're going to see some pictures of this area and a lot of pictures of this area through the presentation. Our consent decree was negotiated with the Elliott Bay Trustees Council. Basically, they allowed us to build a project in lieu of a civil fine. And the project that we agreed to is the Southwest Yard Habitat Project. And I'll be discussing that in the second half of the presentation. The Elliott Bay Trustees Council themselves is mostly regulating agencies, NOAA, Department of Interior's Fish and Wildlife, Bureau of Indian Affairs, Washington's Departments of Ecology, Fish and Wildlife, Natural Resources, and also the Muckleshoot Indian Tribe and the Suquamish Tribe. As we negotiated our consent decree and designed our project and permitted it, the Trustees Council had approvals every step along the way, every major milestone along the way. And so that made getting some of the finer details take a little bit longer to come to an agreement on. But once we got into permitting went really fast for us because all the permitting agencies had already seen our project, they knew about it, and they knew what we were doing. I was brought on with Vigor 5 years ago. And as I started scoping out this project, I realized that this one Southwest Yard habitat project was really 5 projects that we were going to have to build. The first was that we had a substation that was located inside the agreed upon habitat area. The second is King County sent us a letter telling us that they wanted us to get our stormwater discharge out of their combined sewer system. I realized that as we started to dredge and fill, we were going to undermine one of our piers as part of this work that we were doing. And so if we didn't plan on rebuilding this pier at the beginning, it would have turned into a $4 million change order at mid-construction. Then there was the habitat project itself. And then I also told my bosses that I'm going to be shutting down this pier for 3 years and nobody's going to be able to do any work in this slip for 3 years. So if we're going to do any other infrastructure in this area, we ought to do it now because it will never be cheaper or easier to permit. And they decided that they wanted to do some infrastructure improvements for moving a dry dock onto Pier 3. So I'm going to talk about these 2 projects. First, we're going to move into the stormwater one. This is a picture of our pilot treatment system from Clearwater Services. Back in the beginning, as the shipyard grew, Harbor Island's dead flat. And so these very small catchment areas were developed, and each one of these little catchment areas, most of them less than an acre, had an individual outfall to surface water discharge. The only sort of treatment that they had was just BMPs. And around the year 2000, Department of Ecology came to us and said, basically, this is no longer workable. You need to send your stormwater to a combined sewer. And so KPFF did a retrofit on this stormwater system. This purple area basically the collection system got reoriented to go to 4 different pump stations, which would then pump to 3 storage tanks here. And then these 3 storage tanks would be sent to the combined sewer system. If I'm getting a little background noise, it's because I have my contractors out driving piles today. This orange area here, this remains surface water discharge. There's about 12 different outfalls in this area. These yellow finger piers are our operational piers. These green piers here, these became part of our our natural resource damage project with the Southwest habitat. And then these 2 blue areas are just parking areas. So in 2018, King County sent us a letter basically saying, we need you to get your stormwater out of our combined sewer because you're too much of a discharger. And so we plan to retrofit onto our retrofit. We had to remove our dozen direct discharging outfalls as part of our agreement with the trustees. As part of that, we were going to remove all of our light industrial restrictions in the Southwest Yard because we wouldn't have the surface water discharge anymore, or direct discharge anymore. We plan to centralize our stormwater treatment with 1 sample point and 1 point of discharge. And then we also had to add a new pump station and retrofit our existing 4 pump stations, which were rapidly approaching the end of their design life. This is our current King County industrial waste permit. The big thing here is our stormwater discharge allowable is a 0.5 MGD. Even for a facility the size of King County, this is still a huge chunk of their treatment capacity. and is the driver as to why they're pushing us out of their system. Our sanitary discharge is comically small compared to all our sources combined that we're permitted to discharge. This dock water is basically our process water for our work on piers, plus any storm water that falls on our dry docks, because there's no way that we can separate that flow from our process water. We began looking at alternatives. We looked at a AQUIP sand filter from Stormwater RX. We looked at a EC system, and we looked at a chemically enhanced sand filter. The EC system kind of eliminated that one right away. We've used EC systems at this facility before, and they never ran quite right for us. And so we didn't, besides the high capital cost, we kind of, that's why we didn't select an EC system. The Stormwater RX system, the main reason why I didn't like it so much was this did not allow for recirculation. So if the stormwater passed through it and it wasn't meeting our treatment limits, there was no way we could capture that and recirculate it back into our system. And the chemically enhanced sand filter, this system is very close to what we're using for our dock water process water system. The main difference being the chemically enhanced portion. But the sand filters are pretty much exactly what we're already using on site for that system. These are our new stormwater permit limits. Our permit has gone out for public comment and is basically approved and waiting for us to bring our new treatment system online. We were originally hoping to get that system online back in December, but I had to put my stormwater project on hold for 2 months and shift all my labor onto the NRD project, the Habitat project, because we had a far stricter deadline of getting all our in-water work done by the end of February. For our new permit, our copper limits were tighter than what we had hoped they would be, and the zinc limits were tighter than we had hoped they would be. Our influent on our pilot tests, copper is kind of a highly variable source for us. Lead was generally consistent. Zinc is generally consistent. And TSS and turbidity, these, we knew we were going to hit these with treatment regardless of whatever system we chose. We ran the system for a month without a pH addition, and we were getting some treatment on our copper, but not nearly enough to meet the permit limits we were expecting. And our zinc was getting almost no treatment at all. So we added and the main reason why here is that the stormwater at our facility comes in at about a pH 5. Once it falls out of the atmosphere and hits the pavement, it doesn't come into contact with anything that might buffer it into a higher pH. So it's pretty close to its theoretical acidic, carbon dioxide addition for aerated water coming into our system. Once we added the pH, we moved the equilibrium towards a more solid fraction, and we were able to catch much more of the metals on the sand filter. When KPFF and Todd Shipyards did the 2005 retrofit, they basically replumbed the catch basins to a storm scepter hydrodynamic separator, to a pump station, to a force main, to 3 new tanks. Then those tanks went into another force main and discharged to SPU and King County. When we did our retrofit on our retrofit, this portion stayed the same. We added a new storm scepter and a new pump station. And then we put in a flow splitter here so that the water quality treatment goes to tanks 1 and 2. And then we'll go to treatment. Anything that's above the water quality flow gets split off and goes to tank 3. And then that basically operates as a surge tank so that we don't flood out our parking lot with high stormwater flows. And that runs to the city outfall. This treatment combines with the overflow before it hits the city outfall so that we can sample both lines. This is another treatment schematic. So the stormwater comes in here with chemical addition, goes to tank 1, comes out of tank 2, flows to the Connex. It checks to see if it needs treatment. If it does, it runs it through the sand filter. And then it comes back through the Connex. It checks to see if it needs treatment. If it's clean enough for discharge, then it sends it out to the outfall. And then when we backflush the system, water flows backwards through the sand filters into the poly tank, and then that gets routed back to tank 1 with the next round of chemical addition. Some pictures. So as I said, the project got delayed a little bit. On the left here is our brand new pump station 5. This pump kicks on first for low flows. The second pump kicks on, and these two pumps will basically convey the water quality flow. Then if we have any excess in the water quality flow, this third pump will kick on. They all run off VFDs so they can ramp up and down so our treatment system and our tanks don't get too much of a surge into them. Over here on the left is we're in the process of demoing pump station 4. Basically everything except for the pump intakes and the bracing for the plumbing has been pulled out of this manhole. I took this picture yesterday. And as I said, these pumps are right at the end of their 20-year lifespan, and we're starting to have occasional failures on the system. These are our stormwater tanks. These are brand new overflows out of the tank. So if tank 2 and tank 1 get to the point where they're going to overflow, they spill back down. It'll run into a catch basin here, and then this drains out into pump station 4, and it will get recirculated around the yard. Same with our overflow pump tank 3. This unit here is part of the old system. It sits in between these two tanks, and basically it would draw down water out of these two tanks and pump it into the sanitary. This is going to be going offline in the next couple of weeks, and we'll basically be operating just tank 3 as our stormwater tank, while tanks 1 and 2 get retrofit for the new treatment system. This is my new pods that are here waiting to get fit into the new system. And this is my Connex with all the controls. And this is the new pipe racking going in behind the stormwater tanks to carry flows into and out of these tanks. And so that's the stormwater improvements that we're making. And now I'm going to move over and talk about the habitat project, which is a much as interesting of a project as the stormwater project. So this is the area of the shipyard that we refer to as the Southwest Yard. As you remember, this area is all basically direct discharging with just BMPs. This is that original 1918 building that was constructed on site. This is a production building. This is a warehouse. This was an on-pier warehouse. This is a level launch, and we refer to this as Pier 3. This was Pier 2 platform. This was Pier 1, and this is Pier 1A. In between is the shipways. And the way that the shipways worked is you would build a vessel on this platform. It's an inclined platform that slopes into the waterway, and you would use cranes on the sides of it. And so you would weld all your big components flat on the shipways, and then you'd pick them up with multiple cranes, move them into the hole, and then weld them into place. This was a big revolution in shipbuilding that was done during World War II, and they were able to half the production time for building naval vessels for World War II. And so this facility was heavily used during World War II and used up into about 2000, 2005. This buildway was used. These are two old dry docks sitting here. This one is slightly more narrow and about the same length as a Olympic class Washington State Ferry, for perspective. This is where this project sits on Harbor Island, right here on the northwest corner. This warehouse and this warehouse here will show up in a lot of photos, so they're good points of references. When we negotiated out our consent decree, these top three numbers were explicit in the agreement, that we would create 0.3 acres of riparian, 0.4 acres of intertidal marsh, and 2 acres of intertidal mudflat. And these are all delineated by elevation. As a process of building these habitats, we converted 1.5 acres of upland into habitat, removed over an acre of overwater structure, pulled almost 5,000 creosote piles, and again, we eliminated the 12 direct discharging stormwater outfalls in this area. Mudflat on this section of this river has been repeatedly identified as the critical highest value habitat for restoration on the lower Duwamish. And if you think back on that pre-industrialized condition of this area, that's by far the thing that's been lost the most here. And we built basically a pilot version of an intertidal mudflat back when we were doing a cleanup project between 2003 and 2006. This happened to coincide with our previous stormwater retrofit. These two things seem to hit us both at the same time repeatedly. And I'll walk you through a little bit of what we did back in 2003. So this was part of the Todd's Shipyard sediment operable unit cleanup. Everything in yellow was dredged to clean. We had another buildway here on the east side of our facility. So you would construct a vessel here and then launch it sideways into the water. This is our Pier 6, Pier 5, Pier 4. There was a large platform pier here that was completely demoed as part of this project, as part of this cleanup. This is Pier 3. This is what Pier 2 used to look like. This is Pier 1 and Pier 1A and the shipways in between. There was also a finger pier that stuck out here in the middle of this slip that was demoed in 2003 to 2006. So everything in green was overwater structure that remained. The pilot habitat that we built is in this area here where Pier 4 platform used to be. And then we had a little bit of contamination that remained here at the bottom of the shipways that we had to clean up as part of the current project. This is what the pilot habitat looks like. This is about a -3.5 foot tide. This side of the habitat's about a -2. This is about a +2. And I'm standing on Pier 4, taking a picture, looking south, looking upriver. This is our level launch. So if we build a ship inside this production building here, it gets rolled out on this level launch and then moved onto a dry dock. This picture, I'm standing on the launch, looking south towards Pier 3. And this is a little animation that I created for how this area of the shipyard is changing. This is our pilot intertidal mudflat from 2006, the reconstructed corner of Pier 3. This is the shadow for our dry dock to be relocated onto this pier with a vehicle access ramp. These are the piles that we're driving today, is for this ramp here. We reconstructed Pier 2 into just this small sliver where it used to extend all the way out here. And then the ship Pier 1A, or Pier 1 becomes this jetty berm, and Pier 1A becomes this gravel access road. This light green is intertidal mudflat. It's here shown in section. The medium green is saltwater marsh, and the darker green is shrubs and trees. And this black line represents a log wall with root wad trees sticking out into the mudflat area. And these provide little safe hiding places and food sources for the juvenile salmon to come in and hang out. Species of concern. Because this project is part of an environmental settlement and it's going to remain on private property, we can basically hyper focus on juvenile Chinook salmon. We didn't have to worry about other uses of the property, public wanting a nice place to hang out, like a park, or trying to make it a nice place for birds to show up. We can basically just hyper focus on this, on salmon recovery, which is what the trustees wanted. This slide here, I don't want to spend a whole lot of time talking about, other than to say this is something that we are doing. And Vigor has been a supporter for Long Live the Kings for a very long time. And we basically provided a whole bunch of funding to them to hire University of Washington School of Aquatic Fisheries, or of Aquatic and Fishery Sciences, to do some pre-project and post-project monitoring for fish and insects and a fish diet. One of the interesting things that came out of our pre-project sampling is we did not catch any juvenile Chinook salmon in our 4 or 5 sampling events. It could be a couple reasons. First is, in the project area, there's not a whole lot of areas where they would like to hang out. And the one area where they might is here at the foot of the shipways, which was not a really great place to try to cast a net and catch fish. I'll show you why in a minute, but there's a whole bunch of broken pile that's underwater here. And you only have to catch your net on that once before you never cast your net there again. And the planting, the process that went through to develop the planting mix for the habitat, that could be its own presentation as well. Each one of these planting mixes has about a dozen different species specified in it. And the theories here being that, one, a diversity of plantings will provide a diversity of insect population for the fish to eat, which will be better for them. And also, not everything that we plant may survive with the brackish water that we have here in the Duwamish River estuary. But because we have a big diverse planting mix, the hope is that enough things survive that we can get full growth, and that the plantings will take over the habitat the way that we want them to. This is the planting plan. Basically, you have the intertidal mudflat on the inside. There's a migration corridor on the outside with an inlet and an outlet. Salt marsh gets planted first, and then the conifers and shrubs and deciduous trees go behind that. And then this is a gravel access road for SPU. They have a stormwater outfall that discharges in this location. These black dots here are a debris barrier, and it's bowed out partly to help debris that comes in kick out back into the channel, and also so that it doesn't create a static shadow that might become a fish barrier for fish wanting to enter into the habitat. And now we get to the fun pictures. So pre-project photos. This is one of the few times that I've seen a heron hanging out in the project. It has come back since construction has completed. This is Pier 1A. You can see the amount of debris that have washed in here on the shipways. This is a ship block, some more ship blocks here. When you put a vessel on dry dock, you don't actually put the vessel on the dry dock. You put them on these blocks that stand between the hull of the dry dock and the hull of the ship. This is a dead crane that had been sitting out here for years. I had 3 of them that I had to demo as part of the demolition of the shipways. Another dead crane, more ship blocks that have been stored out here. We were able to incorporate this root wad tree into our final habitat. This is an old concrete dry dock that was waiting for demolition. You see a lot of steel panels here on the pier. Every one of these panels covers a hole. Some of them are small enough to just be trip hazards, and some of them are big enough for me to pass through. More debris that had washed up on the shipways and accumulated. Another crane sitting out here on Pier 1. This is my big long warehouse in the background. This is that on pier warehouse here. And this is more stuff that had accumulated in this area around the shipways over the years. This is a substation that I had to replace as part of the project because the end of the habitat, it comes more or less across this area of the photograph. A picture of Pier 2, the on-pier warehouse, more steel panels covering holes. This gangway was not in use anymore. You can see some of the piles here that are under the pier were not in the best condition. This is the section of Pier 3 that got replaced in this area here. And this is a Washington State ferry that just happened to show up on the day I was taking photographs. And another picture of my substation. And this is looking back towards Pier 2, and Pier 1 runs off in this direction on the photo. And the way that the site looks today, we've basically done all of our grading. The habitat is basically completed except for installation of the irrigation system and the plantings, which are going to happen over the next 2 months. The red arrow represents the pre-project photo, and the blue arrow is the current photo. You can see Pier 1 has become the jetty berm. This is the migration corridor coming in on the east side of the habitat. Here's a photo from standing behind the shipways looking towards the west. You can see the head wall of the shipways, a couple of the cranes, a couple of the things that have accumulated over the years. Here's the habitat. This is about a 0-foot elevation tide. The east migration or the west migration corridor had got cut off from the main channel of the river. But you can see how it slopes down here into the mud flat. This is the log wall that separates the mud flat from the riparian. This is standing out on what used to be Pier 1A, looking back towards our warehouse. If you can hear the air raid siren, that just means lunch is over. So you can see the debris on the shipways again. This is what it looks like now. This gravelly area, this is where the salt marsh will get planted. This darker soil is for the riparian shrubs and trees. And then this is the gravel access road that runs out to the stormwater discharge for SPU. Another picture looking in a more northerly direction. You can start to see how much the current of the river had taken its toll over the years on the shipways, and other debris that had just been left on it. These are all ship blocks that have been out here so long they're growing seaweed. This is the migration corridor coming into the habitat. This is looking straight north towards what used to be Pier 1A or Pier 1. And you can see, you know, the transition from mud flat into the salt marsh on the other side with some of the wood. And on the other far side of this is riprap to protect the habitat from large storms coming in from the northwest. This picture is looking down into the migration corridor on the west end. These are all the broken piles that were down at the bottom of the shipways. You can see why UW didn't want to cast their net and try to catch fish in there, and how much nicer it looks with our new migration corridor coming in to the habitat. And this final group of pictures is looking down at our debris barrier. And so this is what our debris barrier looks like. These are composite plastic pile. They are not load bearing, and this is what they look like from afar. I'm standing up on our stairway into our warehouse, taking this picture. And I'll wrap up with a group photo of my 5,000 creosote piles. Are there any questions?
Well, thank you so much, John, for presenting. As John said, if there's any questions, please feel free to either like say them out loud, or you can put them in the chat. But I guess to get started, I do have a question. I'm curious if there's any planned bioretention or buffer of the shrubs and conifers into the habitat area, as in like a runoff.
From that gravel road?
Yeah, from the gravel road or just the surrounding area.
There is a mulch that will get placed down as part of the planting that will help protect it from some of that runoff. And we have to maintain it. We weren't really planning any kind of you know, like a driveway type BMP that you would expect for like a residential development. The expectation is that we get enough grasses and stuff like that that grow into the area that it will function like that once it establishes itself. If we do start getting, you know, erosion rills, then we may have to go back in there and put some jute matting down or something like that to help prevent that kind of runoff.
Awesome, thank you. It looks like we have a question from Steve. He asks, what is the project cost and what is the operations and maintenance cost?
The operation and maintenance, I can't remember off the top of my head. My stormwater project is, I think, just over $6 million now. We've had a lot of cost increases, basically from the nature of working at a 100-year-old shipyard. You find lots of things that you didn't expect. Buildings have come and gone, utilities, there's lots of ghost utilities and abandoned foundations. And that's slowed construction down a lot. It's driven up some costs. And then, you know, there's the construction inflation that's happened really bad during the pandemic. The Habitat project is, I want to say, about 24 to $26 million. And that's had some cost overruns too, mostly associated with utilities that have been, you know, active utilities that have become brittle since they were installed during World War II, shaking apart while we've been driving piles or shaking apart under construction loading. Also, we ended up having to import a lot more fill than we expected to construct our habitat to grade. And so those have been some challenges.
Awesome. If anybody else doesn't have any other questions, I have another question. Has this project inspired any other estuary restoration projects in the area? I feel like I remember you previously were talking about it a little bit last time, but
I don't know. Well, Floyd Snyder is doing some consulting work for other facilities that are on the river. I don't know that there's been anything directly inspired by it yet. That's part of the reason why we are doing the funding the pre versus post habitat or fish monitoring. So I expect that there will be more. There's a lot of interest in the project because of where it is and that it's at an active facility. And I expect that there'll be much more interest once we get that study completed with UW on how much improvement have we seen from the restoration.
cool. I guess like in going into the monitoring, the fish monitoring, is there like have they discussed what their anticipated or like what they're projecting the restoration will be in terms of like juvenile fish or whatever species are planned to use the area?
They haven't projected what they hope. But if we do find any Chinook salmon, it will be an improvement over what we sampled before, and that's our species of concern. We did have a good diversity of insects and fish diet, but it was not as good as some of our reference sites. They used a reference site by the Coleman Dock in downtown Seattle, and they used Jack Block Park restoration site in West Seattle as comparisons. And so we were kind of middle of the road between those two. But we're hoping that we'll be a lot better once our project's completed. And the first year of post-project sampling will be next year. So we get a full year for plants to establish before we do that first round of monitoring post-project.
And how long are they planning to monitor for?
Right now we have them on contract for 1 more year, but we as a facility are required to do it for 15 as part of our consent decree. So we'd have big monitoring events in years 1, 2, 3, 5, and maybe it's just 10, 3, 5, 7, and 10 that we're required to do monitoring post-project. And we may extend their contract out to do those, or we may shift resources.
I think that it's really cool to get research involvement with UW. I think that's an awesome opportunity.
Yeah, we thought it would be good to get actual science on such a big restoration project.
Awesome. Well, does anybody else have any other questions? I'm not hogging the question section. All right, well, I guess if there aren't any other questions, we can go ahead and end a little bit early. Thank you so much, John, for joining us and presenting. I think that this project is really exciting, and I really appreciate you coming out to present.
Oh, sure. I enjoy doing it. So thank you for asking.
Yeah.
Thank you.
I will stop my share.
Okay, sweet.